Good morning, my lovely tens. Right, buddies, here we go again. We're back into online learning this week. I know that quite a few of you are out this week with the self-isolation, and to be honest, so am I. I'm having to work from home as well, but that's all right. You guys have already shown how good you are at the online learning. You didn't have any trouble with it before, and so I bet you this is going to be smooth as anything, just rocking on with online learning. With your tests as well, I know that you guys have just finished your exams and I'm in the middle of marking them still. I'll share all those results with you when I finally get to see you again next week. And yeah, so that's it. So let's keep going on our unit that we started all those weeks ago before the exams. So your title for today is Using the Sine Law. So I'm going to recap with you today some brand new topics next lesson. Cool. So using the sine law is your title. Now, I know it's been ages ago, so you might not remember everything about the sine law because we only did like 2 lessons on it. But here it is one more time in this top corner in case you forget it. So a over sine A equals b over sine B equals c over sine C. The way that that works, again, my buddies, is that they work in opposite pairs, okay? So essentially it's saying a over sine A, in this question 1 here, you're going to just pair up the angle and the side that's, or you're going to pair up the angle and the side that is opposite to it. It sets up a ratio which you're going to be able to solve to work out either side lengths or to work out angles. Now, sine law is brilliant, and cosine law will be brilliant too when you learn about that, but it's brilliant because you don't need to have a right angle triangle, because we definitely had to use right angle triangles whenever we use SOHCAHTOA and whenever we use Pythagoras' theorem. So because we don't need a right angle triangle, sine law is more versatile, and actually students kind of prefer it sometimes to SOHCAHTOA. So let's see if you do. So just for the first 2, I'd like you to actually draw these into your books, just so that you'll have a worked example that you can look back on. But then after that, I don't mind if you don't draw the triangles anymore. So if you want to pause and draw that triangle, that'd be cool. So pause. And you're back, my buddies. So here we go. Here's how it works one more time. So have a little look with me. First things first is the thing that we're after is this, that A there, okay? That's the letter that's marked. Now, it's a side length, and we're going to deal with it first, okay? So here's what you're going to write. You're going to write A over, and it always is like this. It's sine of the angle that is opposite to it. So the angle that's opposite to it is the 46, because if you drew a line out the 46, it would hit the A side, so it's on the opposite side of the triangle to it. So here's what you write. You write A over sine 46. Now, on the other side, my buddies, what it's going to equal to is the other angle that you're given. Now, if you check it out, this 79 is opposite to the 11. Now that's brilliant because those two things are both just numbers, which means we'll only have one letter to solve in our equation, which means we'll totally be able to solve it. So here's what you do. You put the length first, so 11 over sine of the angle opposite, which is 79. Cool beans, buddies? That is pretty much it. If you can do that, that's actually what the content is. That's actually what the topic is. Now the rest of it is just algebra manipulation. I want the A on its own, but it's been divided by a sine 46. So what's the opposite of divide sine 46? Well, you times it. Times sine 46 times sine 46. Now that's cool, because this side goes and it gets cancelled out, leaving you just with A on its own on that side because the sine's cancelled out. And on this side, you're going to be left with the 11. The sine 46 is going to touch it, sine 46. If you want to know why, it's because when you times by sine 46, it's actually the same as timesing by sine 46 over 1. So the top gets times by sine 46, but the bottom only gets times by 1. So that makes them at the bottom stay the same. So this is just over sine 79, and you just use your calculators. Use your calculators to get the answer. Make sure there's a D somewhere in the top line of your calculator. If there's an R or a G, it's going to make wrong answers. So you got to make sure that there's a D in it, and if there isn't a D in it, reset the calculator, which is like shift and then 9, and then depending on the calculator, click clear all. Cool. So here was what we got. 11 sine 46 over sine 79. I got 8.06, and I hope that that's what you got too. 8.06. Now, I'm going to do the next one with you, but if that was too slow for you, that explanation, you should push pause and try it on your own. Okay, and if it wasn't, I'm going to do it with you in a moment. So if you're going to pause, pause. And if not, stay with me. Here we go. So same deal again on this one. The thing that we want to solve is this b, and so here's what you're going to do. B is opposite to the 51, so the formula that we're going to use is this. B over sine 51, because that was the angle opposite, is going to equal, and you just compare it off with one of the signs that's only got numbers in, one of the sides that's only got numbers in. So here we go. This is going to be 4.2 over sine 27, because that was the opposite pair. That's this one, right? Cool. Times both sides by sine 51. So you'll be left with b equals 4.2 sine 51 over sine 27. And from there, it's just a calculator job to get the final answer of b equals, and let's do it, 4.2 sine 51 over sine 27 equals, and I got 7.19 in this case, 7.19 centimeters, like a boss. So I hope that that's okay, and I hope you have your head around finding side lengths. Cool, cool, cool. We did this a little bit already before, but I still thought it was worth a practice because it's been an awfully long time since I've actually taught you and haven't done exam revision or exam weeks. So here you go, buddies. What I'd like you to do first of all is just to look at these four triangles here. The answers are under these squares, but I'd like you just to push pause and just do one of them or two of them or whatever. You can see these ones with the blue arrow. There might be an extra step on them. And spoilers alert, the extra step is you've got to find the angle in the corner too. Yeah, so push pause and see what you get. I'll reveal the answers in a minute. Pause. Okay, and you're back. So I hope that it worked out okay. 6.35 on the first one, so just writing it out, no problem at all. The C was over the 62 because they were opposite, and the 6.1 is over the 58 because they were opposite. It's always sensible to put the variable one first, just because that will leave the letter on the left, which makes it like all the more easy for us. That's how we're used to saying it. Okay, D is a bit trickier because we had to actually get this angle first. It's 40, okay? Didn't do anything special with that. There's 180 in the triangle. I just took away 64 and 76 and got 40. Cool. Leads to an answer of 9.01. Cool. E, no problem at all. It's an obtuse angle, but that doesn't make any difference. It works for obtuse angles too. So E over sine 134, 6.1 over sine 17, 15.0 you get. F's got two of them to work out, but still no problem. That's going to be 45 degrees, just from taking away from 180. F being then 6.06 and G 11.4. So I hope that you feel okay at all of that. So we did a little bit of this last time, but that's all we did really. Okay, what we haven't done yet is this, finding angles, okay? Oops. So finding angles. Now, I'm just going to adjust the formula for us to make it just a little easier to work with. So I'm just going to show you, pretty much, we can use the regular old sine law formula. A over sine A, B over sine B, and C over sine C if you'd like to include it. But the only trouble is that the angle that we're after, like the angles, if we're solving for angles, happen to be on the bottom, which is fine, but is just that awkward thing about we're dealing with fractions. You remember how we don't really like fractions? We always kind of endeavor to get rid of them, don't we? Every single time we ever get a fraction, I'm like, okay, why is it complicated? Because there's a fraction, so then let's kill the fraction. I always end up saying that to you, but since there's so many fraction-y ones, since every single time you do it, you're going to wind up with a fraction, it's easier just to rearrange it now. So I'm just going to show you where the rearrangement of the formula comes from. I'd like to kill both fractions at once, okay? So I'm just deriving. If you're not all the way sure about this, it's okay. I'd like sine A to be on the top, and sine B to be on the top, and the letters to be on the bottom. Here's how you do it, buddies. What can I times both sides by to get rid of these fractions? Well, how about this? If we times both sides by sine A, sine B, and if we times this side also by sine A, sine B, Well, check it out. We can do that awesome scratching out thing. And now this side now doesn't have a fraction anymore. And now that side doesn't have a fraction anymore. So we're totally winning. So on this left-hand side, you're going to get A sine B. And on this side, you're going to get B sine A. Which is kind of cool, but it's still not brilliant. It's not like it's not as ready to go as I'd like it to be. So here's what we're gonna do. I want the A's with the A's and the B's with the B's, just because I know that, yeah, well, that's because I know what the formula is supposed to be, but also because I want the letters to be the same on either side of my equation. So here's what we're gonna do. I'm now gonna divide by the little kind of pair of them. So here we go. I'm gonna divide this side by sine A, sine B, and this side by sine A, sine B. So we're doing the exact same thing on both, right? Cool, because check it out. And you're going to be left with this. You're going to be left with A over sine A equals B over sine B. Now, if there was a third one, if there was a sine C, you could generalize it to that as well, because you could just do it with the B and the C rather than the A and the B, and then you'd have three things equaling each other. So you could do it with the third side too. So hopefully you can see the formula just becomes this. Okay, it's the exact same formula that you dealt with before, so pause it, write it down. Okay, and it's the exact same formula that you did before, because do you remember? Look at this. This is just A over sine A, B over sine B, and C over sine C. This is the same, but with the letters, with the angles on the top. This is better suited for finding angles, because the angles are at the top, but it's the same formula, but just flipped upside down. Okay, it's the same formula, but the other way around. Cool. Promise it'll make finding angles easier. That's why I wanted to do it with you. Okay, was it necessary to do though? No, we could have just gone and used the original formula and just put numbers into that and solved with that. But this gets rid of fractions, makes it a bit easier, so that's why we do it. Okay, couple just to try. It works the same way, okay, buddies? It's exactly the same as the other one. So again, like the last time, I want you to draw these triangles out just so you'll have a good example in your book. But then past that, I don't care if you don't draw them anymore. It's okay. You only have to draw them just when you're learning. You don't have to draw them all the time. Cool. So let's do it. In this case, I'm after this angle, which is labeled little a, which is weird because usually angles are capital letters when we use them with our alphabet, or they're Greek letters if you use them with the Greek alphabet. So here we go. We're after this little a here, okay? Now, because we're after angles, here's what I'm going to do. I'm going to use the angle-y version with the angles on the top. So I'm going to write this. I'm going to write sine, lowercase a, because that's what it was, over 8. So same deal, it was just the angles opposite, and it was just flipped around the other way, that's all. And then same deal on this one, we're gonna go the 32 is paired with the 6, because they're opposites. So sine 32 over 6, and there you have it. Now to get a on its own, just like last time, we're gonna just times both sides by 8 to get the sine a on its own. So that's gonna leave you, my buddies, with cancel, cancel, you're going to be left with sine A on this side equals 8 sine 32 all over 6 on this side. Now, I'm going to be giving you a bit of a spoiler here. If you put that into your calculator, the right-hand side, it's going to be a horrible decimal number here. I'm even going to say what it is. I wouldn't recommend this, but I'm going to even say what it is. It's 8 sine 32 divided by 6. If you put that in your calculator, you get an awkward number. It is 0.706559019. So it makes a big awkward number that starts with 0. Now, that's clearly not an angle, so what we need to do is we need to actually get the angle. The thing is, our letter A here has been signed, right? So how do we stop an angle from being signed? Can you remember from SOHCAHTOA? So we want to know what A is, but it's been signed. What's the opposite of sine? Well, yeah, sine minus 1. So here we go. A equals sine minus 1. So sine minus 1 in both sides. And the whole of this rubbish in here is sine 32 over 6, close the bracket. Now, if you type that into your calculator, you're going to get the angle straight away. So I'm just going to push shift, sine. I actually have mine in ants. So ants equals, and I got 45.0. 0.0 degrees. It's harder to do this in your calculator, but it's not harder theoretically. So just make sure that you get it to work in your calculator, okay? Sweet. Well, have a little go at B on your own. If you're really, really feeling confident, I often skip this step and go right from the first step to the third step to the fourth step. Cool? So see what you think. You ready? Go. Okay, and you're back. So let's see how you've done. Well, here we go. We're after B, so I'm going to do this. I'm going to go sine B over 17 equals, and we're going to go sine 21 over 6.8. Okay, now I'm going to do two steps at once because I'm going to be lazy, okay? So you don't have to do two steps at once, but I'm going to cut a step out. I want B, so I'm going to go B. I'm going to do the rearrangement, so I'm timesing both sides by 17. I'm going to be left with 17 sine 21 over 6.8. But because I've got B on its own, I'm going to have to sine minus 1 that side. So I've essentially gone from here to here. Now, I would only do that if I was feeling dead confident. So if you're feeling at all a bit struggly with this, definitely do that middle step too. So B equals sine minus 1 of that, which means that B equals, and let's just work it out, shift sign first of all, fraction button next, 17 sine 21. Close bracket, bottom of the fraction, 6.8, close the main bracket to the right, and I got 63.6, 63.6 degrees. And there you have it, my lovelies. You've now used sine law to find both angles and sides, which means that I bet you're proper bossing it, proper good at it. Here's what I'm going to get you guys to do. Just not super challenging or anything like that. I just want practice. So my goal here is for you just to practice. I've made you this sheet and I've attached it onto Show My Homework and onto the Google Classroom. I just want you to find the missing angles using sine law. So this is going to be exactly the same as we just did 5 seconds ago. So 4 questions on that, and then 4 questions on finding sides, okay? But this worksheet is just on Show My Homework for you, and have a little go at it. Upload it as a single PDF, so using your cam scanner or using Office Lens onto Google Classroom for me. This is going to count as your homework too, so you won't have anything else to hand in this week. It'll just be this because I'm going to use this one as your classwork and your homework. So I hope that's okay, my buddies. I'm excited to be out of self-isolation. I'm excited for you guys to be out of self-isolation as well. And yeah, I'll see you next week and I'll let you know how your tests have gone then. Keep up the fab work. I know we're already really pro at online learning, so you've got this, my buddies. Upload this when you're done, and that's that. Have a good day. Bye, lovelies!